Okay, we want to review an integration technique known as integration by parts. I used to have the hardest time remembering the formula for this until I realized that integration by parts is just the product rule backwards. So if you remember the product rule, if you have the product of two functions, so let's say we have f of x times g of x, and we want to take that product and find its derivative, then you get the derivative of the first times the second plus the first times the derivative of the second. That's just the product rule for taking derivatives. So if we integrate both sides of the equation for the product rule, we end up with the formula for integration by parts. We just do a little bit of work. Let's see, over here on this side, we're taking the antiderivative of the derivative of something, so those just undo each other. So we have f of x times g of x is equal to the integral of f prime of x g of x dx, so integral of f of x g prime of x dx. Now, how can we use that? Well, if I get one of these integrals alone, let me get this integral alone on one side. So on one side, I'll have f of x g prime of x dx, and then I'll move the other stuff over here. So I have f of x and g of x minus the integral of f prime of x g of x dx. Notice that what we've got here is basically kind of a trade-in formula. If we have some integral, and if we recognize it as the product of two functions, then we could trade that in for something else. We can trade it in for a product minus the integral of a different function. This is going to be handy if integrating f g prime is hard, but integrating f prime g is difficult. So think about it as you're going to take your original integral, recognize it a product of two things, and then apply this formula, and if you're lucky, then this one should be easier to do than the original integral. So you're just going to be trading the integral in. Let's look at an example here. So we need to integrate this, x times the natural log of x dx. Notice, if you look at the formula for integration by parts, you have to think about the thing you're integrating as a product of two things. One thing, f, that you're going to end up differentiating, and another thing, g prime, that you're going to have to integrate, right? So you have g prime, you're going to have to figure out what g of x is. So I need to think about this as a product of two things, part of which I'm going to take the derivative of, and part of which I'm going to integrate. So part that I'm going to differentiate, part that I'm going to integrate. Now looking at this, I can either differentiate the x or the ln x, right? I know how to take the derivative of both those things that are multiplied together, but I do know how to integrate x, right? Integral of x is 1/2 x squared. Integrating ln x, that's tougher. So I'm going to try to differentiate the ln x, since I know that's easy and I can integrate the x. So this you can think of, the derivative of ln x is 1 over x. The antiderivative of x, the integral of x, is 1/2 x squared. See what we're doing here? So this is my piece f, right? This is my piece g prime. I differentiated f, so I got f prime here, and I integrated g, so I integrated g prime, and now I have g there. So notice the formula says if you wanted to integrate this product, ln x times x, which is basically what I have here, I can trade it in for f times g. F times g would be right here, these two diagonal entries, minus the integral of f prime g. So, okay, so that says, just following the formula here, I'm going to trade this integral in, the integral of f g prime, for f g, which is, we have 1/2 x squared times the natural log of x minus the integral of 1 over x times 1/2 times x squared dx. See how I just applied that formula? Well, it's a simple pattern. You start off with what you want to differentiate and what you want to integrate. You differentiate in the one column, you integrate in the other column. You trade in this horizontal line for this product minus the integral of that horizontal line. So you trade in this horizontal line, the integral of this horizontal line, for this product, minus the integral of that horizontal line. Now, this actually helped us because if I simplify a little bit, you have a 1 over x here, and that's going to combine with the x squared to just leave a single x. So we have the integral of 1/2 of x dx, like that. Now this integral is easy to do, right? Can you see how we traded in the difficult integral for an easier integral? The antiderivative of 1/2 x is 1/4 x squared plus a constant. You could even check your work to make sure you're right? That's the beauty of doing integrals, is you can always take the derivative to see if you're okay. If we go to take the derivative here, we lo and behold have to use the product rule. That shouldn't surprise us, right? Because we're using the product rule kind of backwards when we're doing integration by parts. So the product rule says you take the derivative of the first, which is x, times the second, plus the first, which is 1/2 x squared, times the derivative of the second. And now we just take the derivative of this part. We can take the derivative of x to some power, constant power. The constant comes down. Let's see, 2 times 1/4 is 1/2, and we get x to 1 power less. The derivative constant is 0. Hey, lo and behold, we have xlnx plus, see how that x cancels that, so we have 1/2 x minus 1/2 x. We're back to xlnx. Sure enough, this was the answer to our problem. Let's do another one. This time we want to integrate just plain ln x. You might be thinking, wait, if you're going to use integration by parts, you got to think about your function as a product of something you know how to differentiate and something you know how to integrate. Now, I don't see much of a product here, but I do know how to differentiate ln x, and I can think, well, what am I going to integrate? Well, ln x is the same thing as ln x times 1, so just imagine integrating 1. Right? The product of ln x and 1 is ln x, so I'm good here. If I differentiate ln x, I get this. If I integrate 1, I get x. Remember the pattern. Right? This formula says you take, here's f, this is g prime, this is f prime, that's g, so you're going to trade in the integral of fg prime for fg, that's this diagonal product, minus the integral of f prime g. So let's see, we're trading this in for x ln x minus the integral of 1 over x times x dx. Notice that 1 over x times x is just 1, so we basically traded in an integral that we weren't sure about for an integral that's pretty easy to do. X ln x, and the integral of 1 dx is minus x plus a constant. You can go ahead and check and make sure that this works. Use the product rule here, right? The derivative of the first is 1 times the second plus the first times the derivative of the second. Derivative of negative x is negative 1, and the derivative of constant 0. Of course, x times 1 over x, that just makes 1, doesn't it? So all we have left is ln x. That checked. It's perfect.